So, hi guys, good day. So today I'm going to uh, explain and show you how to use our Jamovi with the data analysis, K-test, ANOVA, and regression. So first, we have here our data. So in our data, we have gender, so nominal, so in a type of measure type of nominal. So next one we have our program, so also a nominal, and mathematical creativity pretest continuous. So this is two. So the pretest and the post test. So we have our interest in business, the product acceptance, the time spent on reading reviews. So this is also on nominal. Then we have the mathematical competence and product satisfaction. So that's all for our data. Then we have we're going to start now. First for in our t-test, independent sample t-test. So we do this to find if there is any significance on our data. So we have first here, let's try to find our significant uh, difference. So if there is significant difference in interest in business, so and product acceptance or mathematical acceptance, so we have put this. And then in our grouping variable, we're using gender as a grouping variable. So as you can see here, so let's try to hide this one. So it's calculating our data. So here we have our result. So we only take a look on p-value. So what's in the p-value, we'll find the if there is a significant difference. So if your result in your p-value is less than 0.5, so uh, the result will be significance and the null hypothesis is rejected. So also you can check here, so in our hypothesis, so you need to know if it is two-tailed or not, or one-tailed. So if you want to know if there is a significance in male or in a male group, you can see here, so in a male there is no significance difference. So in short, their mathematical competence is not significant than the female. So let's check in our female. So here in our female, we get the result in mathematical competence. We have 0.03. So in short, there is a significant difference of female in mathematical competence. So it means that a female is more uh, significance on mathematical competence. So as you can see, it's always changing. So it depends on what hypothesis you use. So next we have our, so this is an example only, so you can use time spent in our grouping variable or product acceptance in our dependent variable. So next we have our paired test. So in our paired test, we're using our post test and pre-test data. So in a paired test, we use paired test because we conduct the data on the same group, so we need to use this uh, testing to know the if there is any significance difference. So also here you can use descriptive, so to show the mean, median, and standard deviation and standard uh, error. So as you can see here, so let's see our p-value. So in our p-value, we see here that it is 0.588. So in short, what that this mean? So this means that there is no significant difference on our mathematical creativity pre-test and the post-test. So as you can see here, we have 4.65 and 4.63. So uh, supposedly yung post-test is lumaki kung may improvement ba yung mga bata. So, since hindi lumaki yung or hindi tumaas yung post-test kaysa sa pre-test, in short that hindi effective yung mga pinag-aralan or binigay na mga solutions on improving their learning. So, let's go to our one sample t-test. So here you can use any data, so you can use interest in business, in product, in mathematical satisfactions. Let's put this one, mathematical competence. So as you can see, our p-value is less than 0.05. So in short, there is a significant difference in our interest in business and in product acceptance, in mathematical competence and product satisfaction. So they have a significant difference because it's a less than 0.05. Our p-value is less than 0.05. So that's it for our t-test. So for our ANOVA naman, ANOVA, so we have here our ANOVA. So we have a lot of types of ANOVA. We have one-way ANOVA, the ANOVA itself, repeated measures ANOVA, ANCOVA, MANCOVA, and we have a non-parametric, so one-way ANOVA and repeated measures ANOVA. For us, we will using ANOVA, so this one. So ANOVA is used for a testing if you have more than two groups in your group variables. So here we are going to test our in a mathematical competence. So let's put this one, and then in our gender we have, so let's check if ever how many groups in our program. So in our program we have only two groups, I think. Oh, three groups. So we can use the program as our fixed factors or the group variables. So let's use program for our fixed factors. So let's wait if there is any significant difference. So as you can see, we get a result. So let's always take a look on our p-value. So since it is less than 0.05, it means there is a significant difference in our mathematical competence. So in short, in the program, there is a significance in mathematical competence if you have different programs or courses. So here you can use overall model test to check the As you can see, we have sum of squares, so they are the same. Then also you can use model here. Assumption check, so it is advisable to use this to verify if it is significant. So here in our homogeneity of variance test, we have significance different. So also in our normality test, we have significant. And then contrast, you can check this one. And then estimated means. Also here we will using cohens, so cohens. In Turkey. So let's check. So let's take a look if ever there is a significance on the courses or the programs. So always take a look at this one. So in our p-value, so p sub Turkey, there is a significance. So they are all significant. So in a program of BS education in major in English and BSAD Bioscience and BDE SPE na program, so they have significant different. In our ano naman, BSED Biosci, so the program of BSED Biosci and BDE SPE is meron din silang significant since the p sub Chuki or the p value here is less than 0.05. So that's it for our ANOVA. And then for our regression, so let's check our regression. Hello again guys, so this is our continuation for our explanation on how to use Jamovi. So now we're going to compute our data using person R and regression. So in our person R is used to a test to find if there is a significant relationship between two variables. So let's start on person R. So let's go to regression, then let's choose correlation matrix. So here you just need to choose any two. So I will choose product acceptance and product satisfaction. So as you can see, let's take a look on our p-value here. In our p-value, we have 0.57. So in short, there is no significant relationship among the two variables. So we failed to reject null hypothesis, and there is no significant relationship between product acceptance and product satisfactions because this is greater than 0.05. So that's for our person R. So let's move on to our linear regression. So let's click linear regression. So linear regression is used to predict something about in our dependent variables by using independent variables and group variables. So we have our dependent variables, interest in business, and next in our independent we will going to use mathematical competence. So let's use this one. So here we have 0.02 in r squared, so we'll multiply it by 100, so it will be 12.1%. So in our 12.1% in interest in business explained by mathematical competence. So in our p-value there is a significant, so since it is less than 0.05, so let's check in our, so let's make a formula. So we'll be using ax plus b, or let's convert it into understandable formula. So y as mathematical competence equals to mx plus b. So mx is our estimate in our mathematical competence. So y is equals to 0.331x 0.331x plus 3.009. So that's our formula. So we conclude that uh, every 1 unit increase in our mathematical competence is equivalent to increase of 0.331 in our interest in business. So that's how we predict our variables. So however, if we can add more a covariates, so covariates, and then in our factor we have gender. So let's choose gender. So now we get r squared of 0.3. So multiply by 100, it will be 30%. Explain in interest business is explained by the group of mathematical competence, mathematical creativity, post-test, and gender. So we have here our estimate data. So in our intercept we have 1.5139 and mathematical competence of 0.2282 and mathematical creativity post-test of 0.4288. So we will create our formula. Y is equals to 1.51390 plus our mathematical competence of 0.2282 plus our mathematical creativity post-test of 0.42885. So now we have our equation. So in every unit increase in our mathematical competence is equivalent to 0.2282 in our interest in business, and while in every unit increase of mathematical creativity post-test is equivalent to 1 unit increase of 0.42885 in our interest in business. So as you can see, we didn't added this estimate in our male female because we only put the in equation that are significant or below or less than 0.05 p values. As you can see, it has 0.924 p value, so it is not significant to use. So that's it for my video. Thanks for watching.